Hi everybody, Mrs. Pesic here. We are looking at section 6.2, Law of Cosines. So we talked about the fact that there's like four different cases of like SSA, SSS, SAS, and so on. And there's two cases that are remaining, and that would be the SSS case and the SAS case. All right, and in these cases, it's just impossible to use the law of sines because to use law of sines, you have to have a side and an angle across from it. And so these two cases that we're talking about here, these two cases do not have a side and an angle across from it that we know. All right, so in that case, we've got to switch over and use law of cosines. So in this case, we have here the standard form, and the standard form of law of cosines looks something like this. So it's it's a squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. And you would use this if you had, the SAS situation. All right, if you had the SAS situation, you know sides B and C, for example, and you know the included angle, which would be angle A, and you would plug it in, and you'd be able to find the side across from angle A. All right, we also have these alternative forms. All right, so if we look at this alternative form, for example, this one, basically, if you took this first equation that we have right here, and you solve for cosine of angle A, this is what you would get. Subtract b squared from both sides, subtract c squared from both sides, divide both sides by a negative 2bc. You'd end up simplifying it to this. And this is a nice handy form for the SSS case, because in this case, you could just plug in, I've got a side B, a side C, a side A that I know, put all this in, and then I'm going to end up with cosine of angle A. And then I can just do inverse cosine to get the measure of the angle. All right, and of course we could, use these same formulas for to find cosine of B or cosine of C, and so on. All right, so let's take a look at this first example. We have here, this case, you're trying to find the three angles, all right? And in this case, we know the three sides. So we know that B is 8, A is 6, and C is 12, all right? And so for this problem, okay, so for this example, we're going to find the three angles. We're going to use our formula for law of cosines. And so in this case, we could try and find any of these angles, A, B, or C first, but actually I think we should actually start with the largest angle first. So if we're trying to find the largest angle here, that would be this angle C, because it's across from the largest side. So instead of using this formula for cosine A, we're really just going to say, oh, we want to find cosine of angle C is equal to, that's going to be A squared plus B squared minus C squared all over 2 times A times B. So that's what we want to do here. And so in this case then, the cosine of angle C is going to be 6 squared plus 8 squared minus 12 squared over 2 times 6 times 8. And that's going to give us our cosine of angle C. So let's grab our calculator and plug that in. All right, grabbing our calculator, we are going to be plugging in 6 squared plus 8 squared minus 12 squared. Let's find this here. So I'm going to do all this in one big fraction. So I want 6 squared plus 8 squared minus 12 squared. And down click, and in my denominator, I need a 2 times 6 times 8. So when I do that, 2 times 6 times 8, and I want a decimal, so I'm just going to throw in a decimal point at the end of that 8 and push enter. I'm getting a negative 0.4583 So let me write that down. So cosine of B is equal to negative 0.4583 approximately, but we still want to find the angle C. Now notice if cosine is negative, what we have learned is that cosine is going to be negative in quadrant 2, right? So if we're looking for an angle measure for this triangle, let's back up for a second. This angle could be anywhere between 0 and 180 degrees, right, in a triangle. But I think since the cosine is negative, that's got to be an angle that's in quadrant 2, if you want to think of it that way, over 90 degrees. So basically, that means since we got a negative, that means this is going to be an obtuse angle, that C is obtuse. So how are we going to find this? Well, we're going to do cosine inverse of that negative 0.4583. All right, and so let's just do this on our calculator. I want cosine inverse, so trig button. There's my cosine inverse. I don't want to retype all of this, so I'm going to just do up click and pop it in there like that. And I say enter, and it's giving me 2.04692. So that's the measure of my angle, but that's measured in degrees. So remember, this is our angle C, and so C is turning out to be 2.04, whatever it was, 2.04692, but that's in radians, and so we want to convert that to degrees. And so in order to do that, we're going to take that and we're going to, multiply by 180 and divide by pi. So let's do that on our calculator. So I'm just going to say times 180 and divided by pi. All right, and so when I do that and I push enter, I get 117.3, let's say. So that's my measure for angle C, 117.3 degrees. All right, now that's great. Let's take stock of what was given in this problem and what we know. In this problem, we did one of these kind of setups. Angle A, we don't know. Angle B, we don't know. Initially, we did not know angle C, but we did know the 3 sides, right? We did know that, A was 6, B was 8, and C was 12. I think that was right. Yepers. And then we're trying to find angle A, B, and C, and we just found angle C to be 117.3 degrees. We could use law of cosines again to help us find angle A or angle B, but really at this point it's probably easier to just switch over to law of sines. So let's do that. Let's say we're trying to find angle B next. We can say, if we're using law of sines, we can say sine of, let's go say sine, not sine. Let's try this again. Sine of 117.3 degrees over 12 equals, and let's just say sine of angle B over 8. And if we are going to cross multiply like we learned in section 6.1 and solve, we're going to end up getting, sine of angle B times 12 equals 8 times the sine of 117.3. And we divide both sides by 12. And we really can find the sine of angle B by doing 8 times the sine of 117.3 degrees over 12. Let's do this on the calculator. So I want 8 times sine of 117. So I'm going to do control divided by, and I want 8 times the sine. Well, I want the sine of this angle right here. I'm just going to say my previous answer. So control negative pops that previous answer in there. So it's going to give me sine of 117.28. But you know what? I wonder if it'll let me just change this because I do want that to be in degrees. And then over, what were we dividing by? We were dividing by 12. All right. So if I put that in there, let's see if that's working. That is giving me an answer of 0.59. So pausing here. Okay, so we got that the sine of angle B, sorry about the funky colors here, sine of angle B turned out to be equal to 0.5925, 0.5925, and then that's the sine of angle B, but we want angle B itself. So to do this, we do need to do sine inverse of that answer. So let's grab that calculator. We're doing sine inverse of that. So I go trig sine inverse of that answer. So control negative says, oh, you want sine inverse of the answer? And I'm getting 0.6342, if you will, 0.6342. So angle B is 0.6342. I think that was right, double checking. Yep, and so that is, though, in radians, so again, we still have to convert that to degrees. So we're going to say, 0.6342 times 180 divided by pi. And so when we do that on our calculator, I'm just going to say I want that answer times 180 and then divided by pi. All right, and when I do that, I end up getting 36.3 degrees for angle B. So angle B is 36.3 degrees. So I can go back up here where I'm keeping track of this stuff, and I get 36.3 degrees there. And now I can just add these two up here and subtract from 180. So if I do, let's see, going back to my calculator, I want 180 minus 117.3 minus 36.3. I'm just kind of rounding off. I get 26.4. So this should be 26.4 degrees here. Now, just as a check, something you should always do is check, is my smallest side across from my smallest angle? Is my largest side across from my largest angle? If that's true, then I think you're in good shape and you're done with this problem. All right, so that is an example on how to use law of cosines. And in this example, this was the SSS case where we were given three sides. Let's take a look at example 2. In this case, this is an SAS case. All right, so meaning we have a side, angle, side situation. So two sides and the included angle. And for this one, I think it would be best if we use this form of law of cosines. It's still law of cosines. And so in this case, if we're going to use this, we are going to want to just plug in 16 for B, 12 for C, and 80 degrees for angle A. So let's test this out. We've got A squared, that's what we're trying to find first. That's supposed to say A squared. Let's try this again. So I want A squared equaling, I want 16 squared plus 12 squared minus 2 times 16 times 12 times the cosine of 80 degrees. So I reach for the calculator. That's supposed to be a 16, by the way. So I reach for the calculator. I'm going to do this on the calculator. So I want 16 squared plus 12 squared. I believe that's correct. Yep. And then minus 2 times 16 times 12 and times cosine of 80 degrees. So I want times cosine of 80, but I need to hit that degree symbol there. And now I do want a decimal approximation. So I'm going to say Control Enter. That is giving me a length of 300, well, that's 333.3. But remember, that is A squared. So A squared turns out to be about 333, 0.3, and then I just need to take the square root of both sides, and I end up getting A equaling what? Let's see, so I'm going to take square root of that answer, Control negative, and I'm getting 18 point, I'll say 18.3 if I'm rounding to the tenths place. So I'm getting A is 18.3. So again, let's keep track of what we started with. Whoa, that's not what I wanted to happen. Let's try this again. That also. So in this problem, if I'm keeping track of the given information, A, B, C, I don't know what that little thingy is. Let's get rid of that. That's supposed to be an equals. So I am told that angle A is 80 degrees. I was told that B was 16 and C was 12. And we're trying to find these remaining three pieces. And we just found that that side A was 18.3. At this point, it probably is easiest to switch over to law of sines. So let's do that. We're going to say sine of, 80 degrees over 18.3. That's really, sine of A over A equals, and let's just do sine of angle B over the length of B, which is 16. When I cross multiply here, I'm really going to get that the sine of angle B is going to be these guys multiplied together. That's 16 times the sine of 80 degrees divided by this guy here, 18.3. So grabbing the calculator, I want 16 times sine of 80, control divided by 16 times sine of 80 degrees, there's my degree symbol there, over, what do I want in the denominator? I need 18.3. All right, I'm getting 0.861 for the sine of angle B. Sine of angle B, that's supposed to say sine of angle B, getting kind of sloppy here. Sine of angle B is equal to 0.861. 0.861. And remember, I want to find angle B, not just the sine of angle B, so I do need sine inverse of 0.861. That's supposed to be 0. And so when I do that on my calculator, I'm getting angle B. So I want sine inverse of that answer, and I am getting 1.037 for angle B. Angle B is 1.037, but what units is that? That is radians. So don't forget that we need to say, oh, I want to convert that. So I'm going to multiply this by 180 and divide by pi. So let's do that to get a degree measure. So times 180 and then divided by pi. And I'm getting that the angle is 59.4. So angle B is 59.4 degrees. So let's go back up, pop that in here, 59.4 degrees. And now I can just add these guys up and subtract from 180 to get angle C. All right, so I want 180 minus 80 minus 59.4. I'm getting 40.6 for this last angle here, 40.6 degrees. Let's check. My largest angle is angle A, and it's across from my largest side. That's good news. And my smallest angle is angle C, and it's across from the smallest side. Okay, so that's example 2. Let's take a look at example 3. In this example, the problem says in a softball game, a batter hits the ball to center field. The center fielder then throws the ball to third base as shown. The distance from the center fielder to home plate is 240 feet, and the distance between the bases is 60 feet. How far did the center fielder throw the ball? So in this example, let me slide this up a little bit so we can see it right next to the words here. In this example, here's home plate right here, and the ball's getting hit all the way out to the outfield, center field right here, and then the center fielder is throwing this ball to third base, which is right here. So we're really trying to find that distance of that throw. So in this case, this to me looks like, if I kind of draw a little model of what this triangle looks like this, We know this angle, right? That's 45 degrees. I'll call that angle A. And we know, this side, let me get a different color here. Let's see. I know this side is 60, and I know this side is 240. So that to me looks like a side angle side relationship. And if it's a side angle side, and I'm trying to find this length here that we're calling D, then I'm going to use that model that we had that was the alternate form. So in other words, I want A squared equaling B squared plus C squared minus 2 times B times C times cosine of angle A. Let's see how well I remembered that. Is that accurate? B squared plus C squared, where is it? B squared plus C squared minus A, no, that's not the one I wanted. Whoopsie, back up. I wanted this one, B squared plus C squared minus 2BC times cosine of A. And I think that's what I have here, B squared plus C squared minus 2BC times cosine of A. All right, so in this case, we're going to plug in what we know. So that means A squared, which is really this length here, right? That's what we're calling D, is going to be 60 squared plus 240 squared minus 2 times 60 times 240 times the cosine of the angle in between the 60 and 240, which was 45 degrees. So let's grab that calculator. We're doing 60 squared plus 240 squared minus 2 times 60 times 240. How's that looking so far? Okay. And then times cosine of 45. So times cosine of 45. I do need to push the degree symbol here. And so when I do that, I'm getting 40,835. A squared is 40,835, I believe. And then we're going to take the square root of both sides. And when we take the square root of both sides, we end up getting A, which is the distance that this center fielder threw the ball. Oh, it was 835. Yeah, I had it. Okay, so then we're going to take the square root of that answer. And when we do that, we get 202 feet. So that center fielder threw the ball about 202 feet. All right, and we've got one last example to look at. And this one says a ship travels 40 miles due east and then changes direction. When the ship has traveled 30 miles at this heading, it is 56 miles from its point of departure. So what's happening here? We're starting off, the ship is starting off like right here. It's going 40 miles due east. That was really sloppy, but you get the idea. And then it starts heading off in a different direction. We don't know what direction, but it's heading off in a different direction. And it goes for 30 miles in that direction. And once it does that, it is actually ends up being 56 miles from where it started. All right, so if that's the situation, sure looks like we have all three sides of a triangle. So that looks like the SSS case, in which case we probably want to use our, our model that says, cosine of angle A equals, B squared plus C squared minus A squared all over 2BC. All right, this question is actually asking for the bearing from point B to point C. And we've talked about bearings, but the best way to get the bearing is to picture a north-south line here and then try and figure out, what this angle would be. If I had to give a rough estimate for this bearing, I would say it's going north mostly, right, to go get from B to C, north maybe, I don't know, I'm just going to make something up, like 30 degrees east. That's just my estimate. I'll say estimate here. All right, that's my estimate of what this would be. Okay, so just for that. But we don't know what it is until we work it out. So let's do that. So I think gets rid of that. So I think what we really want to do is find this angle and that'll help us get the bearing. All right, so in order to do that, I think we need to use this cosine A form, but you know what? Really, we're trying to find cosine B, if you will, if you want to think of it that way. So we're really going to do cosine of angle B equals A squared plus C squared minus B squared over 2 times A times C, where this is my A, this is my B because it's across from angle B, and this is my C because it's across from angle C. So in this case, I'm going to do cosine of angle B equals 30 squared plus 40 squared minus 56 squared over 2 times 30 times 40. All right, and so we grab our calculator and put that in. And control divided by, I want 30 squared plus 40 squared minus 56 squared. And then I want this over 2 times 30 times 40. I do want a decimal. I'm going to pop in a decimal point so that the answer will be a decimal. I get negative 0.265. So let me write that down. So we got cosine of angle B is negative 0.265. And so that's the cosine of angle B. So to find angle B itself, you know that that means we need cosine inverse of negative 0.265. So when we do that on our calculator, cosine inverse of that answer, cosine inverse of that last answer, and that's going to give me 1.839. So with 1.839 as my, oopsie, lost things, equals 1.839. That's my angle B, but that's in radians. So let's convert that to degrees. So times 180 divided by pi. And when we do that on our calculator, let's see, lost where I was. I'm down here. I want this answer that we just had times 180 divided by pi. And when I do that, I'm getting 105.4 approximately for angle B is 105.4 degrees. Okay, so going back up to our picture, that means this angle is 105.4 degrees. That's what we just worked out. So if I'm trying to find the bearing, and I know that from A to B is east-west, so if I draw a north-south line, I'm trying to draw the straightest one I can, I know the whole angle is 105.4, but this much of the angle is a right angle, right, 90 degrees. So we can subtract to get this angle here. So what does that turn out to be? I want 105.4 approximately minus 90. I'm getting 15.4. That's this little angle here is going to be 15.4 degrees. That's this one right here. And that means that my bearing, I was a little bit off on the bearing here. Let me erase this a little bit. So I think that I would answer for this that the bearing is going to be north 15.4 degrees east. All right. Let's see. One last thing to talk about from this section, and that is another cool area formula for triangles. This one is called Heron's area formula, and it goes like this. Given any triangle with sides of lengths A, B, and C, the area formula is given by square root of S times S minus A times S minus B times S minus C, where S is the semi-perimeter. All right, what's a semi-perimeter, you ask? Well, it's just half of the perimeter. So take the perimeter, A plus B plus C, and divide by 2. So this is a great, nice, easy formula. Thank you, Heron, whoever you are. And then the reason why it's so nice is because it's just a quick formula. You just plug in the side lengths, A, B, and C. After calculating the semi-perimeter, you're plugging that in for S. So let's give this a whirl, shall we? We're going to try this last example. And for this one, let me move this up a little bit. So we're trying to find the area of the triangle with sides 5, 9, and 8. So let's start off by finding the semi-perimeter here. So that's going to be equal to 5 plus 9 plus 8 divided by 2. So when we do that, what is that? That's going to be 14 plus 8 is 14 plus 8 is 22 over 2. I'm thinking it's 11. All right, you guys hopefully agree with me. Okay, so if that's 11, I'm going to plug that in here. That's my 11. 11 times 11 minus 5 times 11 minus 9 times 11 minus 8. And we want that to be our, or that is going to be our area. So let's grab the calculator and do that. So I want square root of 11 times the quantity 11 minus 5 times quantity 11 minus 8 times the quantity 11 minus 9, close parentheses. Is that what I wanted? Let's see. 11 minus 9, 11 minus 8. Yeah, I got them in different order, but I think it's all good. And so I want a decimal for this, so I'm saying Control Enter, and it's given me about 19.9 for this. So the area of this is 19.9, and whatever the units were, let's say, you know, these were centimeters, 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 then this would be 19.9 centimeters squared for the area. All right. Okay, and that is, ignore that. That's it for this lesson, and thanks for watching.